When it comes to AI, one of the most exciting areas is how machines can understand both images and text together. And now, Hugging Face has just released something really big in this space. It's called FineVision. This update was officially made public on September 6, 2025, and honestly, it could completely change how AI models learn to see and understand the world. So now let's talk about what exactly is FineVision. In simple words, FineVision is a huge open source dataset that Hugging Face has created for training something called Vision Language Models or VLMs. Now, Visual Language Models are special types of AI systems that don't just read text like ChatGPT, but they can also see and understand images at the same time. FineVision is the collection of data that helps these models learn both skills together. Now let's talk about the size of this dataset. And trust me, it's massive. FineVision has about 17.3 million images, which means millions of different pictures from different domains. On top of that, it contains around 24.3 million samples. Each sample usually pairs an image with some text like a question, caption, or description. It also includes 88.9 million question and answer turns, which basically means the dataset teaches the AI how to answer questions about an image. And all of this adds up to almost 10 billion tokens of information, which is like the building blocks of language. Altogether, the dataset is about 5 terabytes in size. That's huge for an openly available AI resource, right? So, why does this matter? Because until now, most big datasets of this scale were private and locked inside big tech companies. FineVision is different. It's open source, which means anyone from researchers to developers or students can use it. It's currently the biggest public dataset of its kind, and it can help AI models become much better at reasoning, problem solving, and understanding the connection between images and text. In short, FineVision is a breakthrough that gives the AI community the same kind of powerful data that was previously only available to a few companies. Now let's talk about the quality of the data inside FineVision. Because it's not just about having a huge dataset, the data also needs to be clean and reliable, right? Hugging Face spent a lot of time making sure FineVision isn't just big but also useful. First, they work on something called data application. In simple words, that means they removed repeated or duplicate images and questions, so the model doesn't get confused by seeing the same thing again and again. This also helped reduce something called benchmark leakage. Normally, when datasets overlap too much with the test sets used for measuring performance, it gives a kind of unfair advantage. Other datasets have about 2 to 3% leakage, but FineVision has brought this down to just about 1%, which makes the result much more trustworthy. Second, they made sure to check the quality of the question and answer pairs. They used advanced AI models like Quen to score the data on different points. For example, is the text written properly and easy to read? Is the question actually relevant to the image? Does answering the question really depend on the image? Or could it be answered without looking at it? And does the question actually match the image shown? By doing this, they gave each piece of data a kind of quality rating. But here's the interesting part. When they tested training models with only the high rated data versus using all the data, including the lower rated ones, they found that keeping everything actually worked better. This shows that in AI training, having more diverse data is often more powerful than just keeping only the perfect examples. In short, FineVision is not only massive in size, but it's also been carefully cleaned and checked, making it one of the most reliable open datasets available today. So now that we know how big and clean FineVision is, let's look at what kind of skills it actually helps AI models learn. The dataset is designed to cover 9 different categories of tasks, and each one teaches the AI something unique. The first one is General Visual Question Answering, or VQA. This is where the AI looks at a picture and answers a general question about it, like what is the person doing in this photo, or how many dogs are there. Then we have OCR based QA. OCR stands for Optical Character Recognition, which basically means reading text from images. So if there is a picture of a sign, a menu, or receipt, the AI can read the text and answer questions about it. Next is chart and table reasoning. Here, the AI learns to read graphs, charts or tables and explain what they mean. For example, if you show it a bar graph, it should be able to tell you which bar is the tallest or how values compare. There is also science reasoning, which is all about diagrams, scientific images, and visuals you would normally see in textbooks. The AI can answer questions like which part of this diagram shows the heart, or what is happening in this chemical reaction picture. Another big one is captioning. This is where the AI generates a description of an image, like a boy riding a bicycle in the park. It's one of the most common tasks in vision language learning. Then comes grounding and counting. This means the AI can identify specific things in an image, like point to the apple, and also count objects correctly, like how many chairs are there in this picture. One of the really exciting new skill is GUI navigation. This means the AI can look at user interfaces like apps or websites and understand where things are, like which button to click or which menu option to choose. That's very useful for building smarter AI assistant, right? We also have pointing tasks. This is when the AI needs to point to or highlight a certain area in an image. For example, show me where the cat is sitting. And finally, document reasoning. This is where the AI looks at documents like forms or PDFs and answers questions by combining both the text and the structure of the document. Now, what makes FineVision special is that it doesn't just cover the old basics like VQA and captioning. It also includes these newer, harder skills like GUI navigation, pointing, and document reasoning, which most earlier datasets never had. This means models trained with FineVision will be much more capable in real-world scenarios, not just academic benchmarks. Alright, now let's get to the most exciting part. How well FineVision actually performs when compared to other popular datasets. Because at the end of the day, the real test is whether models trained on it can do better than before. And the answer is yes, by a huge margin. Models trained with FineVision consistently outperform those trained on other well-known datasets. For example, compared to LLAVA, FineVision trained models perform 46.3% better. When you compare it with Cloudrun, the improvement is 40.7%. And when against Combine, which is another strong dataset, FineVision still beats it by 12.1%. These improvements aren't just on one or two tests, they show up across a wide range of benchmarks. For instance, FineVision models scored higher on datasets like AI2D for diagram understanding, Chart QA for charts and tables, Doc VQA for documents, Science QA for science reasoning, and OCR Bench for text in image tasks. Basically, no matter what type of vision language challenge you throw at it, FineVision trained models come out on top. On average, across 10 plus benchmarks, FineVision gives about a 20% overall improvement compared to older datasets. That's a huge leap in the world of AI, where even 2 to 3% boost is usually considered impressive. So, if you're into AI or just curious about where the future of technology is heading, you should definitely check out FineVision on Hugging Face. I will leave the link in the description so you can explore it yourself. And as always, if you found this video helpful, don't forget to like, share, and subscribe to the channel. And also drop your thoughts in the comments. I would love to hear what you think about this new update.